In reviewing the results of our analysis, so far we've focused on stress plots. Let's move on now and take a look at the next item in the results folder, displacement. This is where we can examine how this plate deforms when it's loaded. I'll double-click the plot to activate it. What I'm looking at here is the resultant displacement. This takes into account deformation in all directions. As you might expect, the blue areas where the plate is fixed have not moved very much at all. While the red areas on the side where the force is pulling, we see the maximum amount of deformation. You can use the same animation and clipping tools here in this displacement plot as we saw earlier for the stress plots. However, in this case, I want to know precisely how much the end of this plate is moved. This might be important if my design has limits on how much longer this plate can get during loading. If it stretches too much, I might end up with interference between this plate and another component in my design. The first thing I wish to do is isolate deformation in the X direction. This is the direction of the pulling force, and it's the only direction of interest to me for my design purposes. By the way, I know it's the X direction because it's indicated by the triad in the lower left corner of the graphics window. Although deformation in the Z and Y directions will exist, it's expected to be minimal based on our testing setup. I wish to completely ignore deformation in these directions so I can focus on the X values that are important to me. To do this, I'll right-click on the Displacement 1 plot and select Edit Definition. This brings up the Displacement Plot Property Manager. From the drop-down list, I'll select X Displacement. Again, this will isolate deformation in the X direction, which is the only direction that's important to me for this exercise. Next, I'll set units for this plot to inches. In the Deformed Shape section, I have one extra setting to show colors that I didn't have in the Stress Plot Property Manager. This is useful if I just want to show the deformed shape of the part without a color scale. I'll leave this checked and click OK. Notice the deformed result icon on the simulation toolbar is depressed. I can use this icon to toggle the deformed shape on and off. Notice the colors are not affected, just the shape of the model. The maximum displacement in the X direction is just under 4/1000ths of an inch. I'm reading this value from the top of the legend. Remember, this legend is automatically configured to go from the minimum value to the maximum value. If you're interested in values at specific points along the plate instead of the overall maximum, you can use a probe tool to determine exactly that. The probe tool will allow you to investigate the displacement of any point in the mesh of this model. Because the probe tool will be reporting values of points that lie on the mesh itself, it's helpful to display the mesh. To do this, I'll right-click the Displacement 1 plot and go to Settings. The Boundary Options section allows me to enable the mesh. I can also set this to None, and no edges will be displayed at all. In this case, I'll set the boundary conditions to Mesh. While we're here looking at the Settings Property Manager, take a look at the other items we can change here. The first option allows me to set the fringe display to either points, lines, discrete regions, or the continuous fringe we're used to seeing. The deformed plot options allow me to superimpose the original undeformed model over the deformed plot. This is a great visualization tool to emphasize how the deformed model differs from the original. Just keep in mind that the deformed shape is exaggerated. For now, I don't wish to superimpose the original model. I simply want to display the mesh. With this selected, I'll click OK. Now that the mesh is shown, I can use the Probe tool to examine the model. I can activate it by right-clicking on Displacement 1 in the Simulation Study tree and selecting Probe, or I can find it in the Simulation drop-down menu in the Results Tools section. Or I can find it in the Probe icon on the Simulation toolbar. The Probe dialog box will appear. Notice also that the plot has changed. It's no longer exaggerated or scaled up. This makes it possible for me to probe a point on the mesh precisely. As I click on the model, the results are displayed in the dialog box for each point selected. If I zoom in, notice the points I'm selecting are not randomly placed on the part. They're nodes on this mesh. Nodes exist at the vertices of the elements, as well as the midpoints of the element edges. In the dialog box, you can choose to save the list of values, you can plot the values in a graph, or you can clear the list and select one point at a time. At this point, I'll close the Probe Property Manager and I'll hide Plot 1. That was a look at how a displacement plot might be used. The next type of plot available in the Simulation Study tree is a strain plot. Although calculating strain is a fundamental step in order for simulation to calculate stresses and other information, strain has little direct value to our design efforts. For this reason, we'll skip over strain plots and move on to other types of plots.